Hi guys, welcome to class. Today we are going to be building on a skill that we practiced last week, which is solving for an unknown value in an equation or a diagram, and oftentimes that unknown value is represented by the letter X. So last week we worked on one-step equations. This week we're going to work on two-step equations when solving for X. To begin, I'm going to share my screen, and we are going to look at a cute chant that I wrote that will help you remember the steps we need to take in order to solve these problems. So I'm going to repeat it once and then we'll repeat it together. I know it's cheesy, but I promise you when we're working through these problems, this will help you remember the basics. So I'm going to go first, then we'll repeat together. So the chant goes, get X alone, get X alone, undo the operations by using their opposite. What you do to one side, you must do to the other. Keep the scale in balance and get X alone. All right, that's our basic. On the count of 3, we're gonna all sing it together. Unmute yourselves, don't be shy. I know it's gonna sound really weird, but here we go. 1, 2, 3. Get X alone, get X alone, undo the operations by using their opposite. What you do to one side, you must do to the other. Keep the scale in balance and get X alone. Awesome, great job, guys. So based on our chant, our work with these problems is going to be the same. Our intention is to get X alone and solve for that value. So now that we have reminded ourselves the process, we're going to go over to our scale on the left side of the screen, the diagram, which is a diagram of a scale. So let's take a look at what we have on our scale. We have on the left side of our scale 2 identical boxes, and based on our key, we understand that we do not know the weight of these boxes. They're represented by the letter X. We also have, in addition to those 2 boxes, 6 1-pound boxes, cubes, squares. That's the left side. On the right side, we have 12 1-pound boxes. And those 12 1-pound boxes are the same 1-pound boxes that are on the left side of the scale. We also notice that our scale is balanced. It is at equilibrium. What's on the left side equals what's on the right side. So I want you to think real quick about how we might write a mathematical equation to represent what's going on in the scale. Think about it for 2 seconds. Awesome. All right, so let's begin with what we have on the left side of the scale. We have 2 boxes represented by the letter X. So what we're going to do is that will be represented by 2X. We also have, in addition to those 2 boxes, 6 1-pound boxes. So that will be represented just by the number 6. But we realized that those 2 quantities added together equal the entire weight on the left side. So there's a plus sign. We bring down our equal sign from our scale because our scale is at equilibrium. And on the right side, we have 12 1-pound boxes. So we'll add our number 12. Now we have an equation that represents what's happening on the diagram. But we need to get X alone in order to solve for the X value. So I want you to think of how we might add, subtract, move some of these weights around our scale in order for us to get X alone. But we need to be careful. If I want to get X alone, it's super easy for me to just subtract everything and leave one X box on the left side. But if I do that, our scale is going to become unbalanced. If I take all these off the left side, our scale is going to tip. This is going to go down and this is going to go up. We need to keep it balanced. So if we go back to our chant, we remember that we can add and subtract things. We just have to do it to both sides of the scale. So what we're going to start with, what's super easy, it's let's get rid of the 6 1-pound boxes on the left side of the scale. All right. So if I do this to the left side of the scale, Kira, what do we need to do to the right side of the scale?
You got to subtract from the other side too.
Awesome, great, yep. What we do to one side, we must do to the other. And now our scale is still balanced, but we've gotten rid of some of those extra numbers, all right? So now we're gonna move to our equation. How do we mathematically represent what we did on the scale in our equation? Tira, what did we do?
You have to minus 6 boxes from both sides.
Right, so we minus 6 boxes. We also just need to show that in our math. So we need to subtract 6 from each side of our equation. When we do that, we are now left with an equation that's 2x. We had a positive 6. We took 6 away. We're left with 0, so they cross each other out. We still have our equal sign because our scale's equal. And Emma, what's 12 minus 6?
6.
6. Look at that. So now we have an equation that looks familiar, right? We worked on these last week. Our scale is still in balance. And now we just add one more step and we can get x alone. So let's see, Kira, what's the next step? What do we need to do?
So I think to get x alone, you'd probably, since x times 2 is what's happening on the left side, you'd probably divide by 2 on both sides.
Right, exactly. So we just have to undo the multiplication by using its opposite, which is division. So we divide by 2 on both sides. Our 2's will cancel out on the left side, leaving us with a single x. That's what we've been hoping for. And then, Emma, what's 6 divided by 2?
3.
3. Awesome. So our x equals 3. The weight of our x box is 3. And in order to make sure that we're correct, we can go back up to our diagram. We can write that these boxes are now 3. Tira, what's 3 plus 3?
6.
6. So our total weight over here is 6. And on the right-hand side of the scale, we have 6 1-pound boxes. Our scale is equal, and we have found our value of our missing unknown variable. And that's how we're going to start solving two-step equations. Yay! And I will unshare my screen, and we'll do some practice problems, but we're done.